Question 1. To illustrate this point when conducting a site evaluation for a commercial rooftop solar PV installation in Atlanta, Georgia, Mr. Alvarez observes nearby HVAC units mounted on curbs that cast shadows on the southern section of the roof. The building has a low slope surface and minimal parapets, with consistent sun exposure apart from the HVAC units. Mr. Alvarez must also consider seasonal sun angles and potential debris accumulation near drainage points. Given this situation, what should Mr. Alvarez prioritize in his assessment to ensure optimal energy output? A. Install panels directly adjacent to the HVAC units to maximize space utilization. B. Use the northern section of the roof since it is free from shading obstructions. C. Perform a shade analysis using a solar pathfinder and adjust the array layout accordingly. D. Relocate HVAC units to eliminate all shading risk on the southern exposure. Answer. Correct answer. C. Explanation. A comprehensive site assessment includes performing shade analysis to evaluate solar access throughout the year. Annex 690.4d and NAPSET best practices. Using a solar pathfinder or similar tool helps determine precise shading impact and array placement while relocating HVAC units. D. Might seem ideal. It is often impractical and costly. Northern roof faces. B. Typically optimal exposure in the northern hemisphere. Placing panels next to HVAC units. A. Ignores critical shadow impact. Shade analysis ensures maximum system performance and code compliance. Question 2. While examining a residential solar PV installation with a hybrid inverter, installer needs to decide on the appropriate placement of disconnects and overcurrent protection devices. The system includes an AC-coupled battery backup, grid-tie connection, and rooftop panels located over 40 feet from the main service panel. What is the most compliant and practical configuration regarding system safety? A. Install only. A fused AC disconnect next to the utility meter. B. Install DC and AC disconnects at accessible locations and include overcurrent protection near source circuits. C. Place one combined AC disconnect on the roof to simplify maintenance. D. Skip additional disconnects since the inverter includes internal breakers. Answer. Correct answer. B. Explanation. Per NEC 690.13, 690.15 and NEC 705.12. Separate AC and DC disconnects must be installed and readily accessible for emergency and maintenance operations. Overcurrent protection devices (OPT) are required near the source circuits, e.g., at the combiner box or inverter input to prevent conductor damage. Option lacks DC protection. Option C violates the accessibility requirement. Option D is incorrect since internal breakers are not sufficient for code compliance or firefighter access. Proper configuration ensures safety, code compliance, and grid interconnection approval. Question 3. Given the circumstances, Mr. Bennett is integrating a lithium-ion battery storage system into an existing solar PV array for a critical healthcare facility. The system must provide both time-of-use optimization and emergency backup during utility outages. The batteries will be installed indoors in a mechanical room with limited ventilation. Which of the following is the most important design consideration Mr. Bennett must address? A. Maximize the number of batteries to store the most energy. B. Connect the batteries directly to the utility service panel. C. Ensure appropriate ventilation and thermal management of the battery enclosure. D. Install batteries in the roof cavity to save interior space. Answer. Correct answer. C. Explanation. Indoor battery installations require adequate ventilation and temperature control, especially with lithium-ion batteries per NEC 700 6.10 09540 and in FPA 855. Thermal management is crucial to prevent overheating and thermal runaway, particularly in confined spaces. Option ignores safety. Option B may violate interconnection standards without proper transfer switching. Option D is structurally risky and could expose batteries to excessive heat. Prioritizing proper thermal and environmental conditions ensures performance and fire safety compliance. Question 4. Throughout the course of commissioning, a solar PV system tied into a smart inverter platform is Kahuri observes inconsistent voltage readings across several strings of panels and notices lower than expected power production. The site has passed all electrical inspections and visual checks show no damaged equipment. What should be her first technical action? A. Replace the inverter to eliminate internal fault possibilities. B. Shut down the system and request a re-inspection from the OJ. C. Performance of tracing to diagnose string level discrepancies. D. Assume underperformance is due to seasonal weather variations. Answer. Correct answer. C. The explanation, Roman, of cuff tracing is a standard commissioning and troubleshooting method used to assess the electrical performance of each string or module per IC 62446 and NEC 690.8A1. It helps detect mismatch, shading, degradation, or wiring issues. Inverter replacement, they should only follow confirmed internal faults. Option B is unnecessary without identifying a specific code violation. Seasonal changes D would affect all strings, not isolated one. Remnant of testing ensures system reliability and validates system performance against design expectations. Question 5. From a practical standpoint, what occurs in a grid-tied solar PV system when the inverter senses a higher grid voltage than the programmed operating range, and what is the inverter required to do in such a situation? A. Continue operation to prevent solar generation loss. B. Automatically shut down until manual reset is performed. C. Increase its output voltage to match the grid. D. Cease exporting power and isolate from the grid. Answer. Correct answer. D. Explanation. Smart inverters must comply with E1547, which mandates anti-islanding and grid support functions. When grid voltage exceeds limits, typically plus 10% of nominal, the inverter must cease exporting power to avoid damaging utility infrastructure or causing instability. Option violates safety standards. Option B is incorrect since most inverters have automatic reconnection protocols. Option C is dangerous as it would worsen the overvoltage. Inverter disconnection prevents unintentional islanding and ensures safe grid operation. Question 6. Illustrated by Mr. McBride's attempt to replace faulty combiner box in an outdoor ground-mounted PV system, he encounters an older model lacking surge protection. Given this opportunity, he decides to upgrade the box. Which feature should the new combiner box include to best meet current standards? A. Dual-pole circuit breakers only. B. Aluminum enclosure to reduce weight. C. Integrated surge protection device (SPD) rated for EC circuits. D. Fused connections instead of breakers. Answer. Correct answer. C. Explanation. Modern PV systems must include surge protection, especially in outdoor installations susceptible to lightning per NEC 690.17 and 705.12 D4. Integrate SPDs protect downstream electronics like inverters. Option A. Lack surge protection. Aluminum enclosures B. Do not improve electrical protection. Fuses D. Are permitted but don't offer transient suppression. SPD-rated combiner boxes ensure longer system life, reduced maintenance, and better compliance with updated codes. Question 7. In response to customer complaints about high electricity bills even after solar panel installation, Richards reviews the system installed last summer. The customer's consumption has increased due to the addition of heat pump HVACR unit. The original system was sized based on past usage data. What should Richards do to correctly address this issue? A. Recommend reducing HVAC usage to match solar output. B. Replace all panels with higher wattage versions. C. Recalculate the load profile and suggest system expansion if needed. D. Ignore the complaint since the system met initial specifications. Answer. Correct answer. C. Explanation. System sizing must match the current and projected load per NEC 705.12a and best practices outlined in the Solar Ready Buildings Guide. When energy usage increases, installers should perform a new load calculation and assess whether system expansion or energy efficiency upgrades are feasible. Option A limits customer comfort. Option B may be inefficient and costly. Option D neglects professional responsibility. Load reassessment ensures the system aligns with customer needs and utility billing. Question 8. In the absence of battery storage, what happens during a utility outage to a grid-tied solar PV system that participates in net metering? A. It continues supplying the home using solar energy. B. It shuts down to prevent islanding and grid backfeed. C. It stores excess energy in panel capacitors. D. It switches to direct DC supply for appliances. Answer. Correct answer. B. Explanation. Grid-tied systems without storage must disconnect during outages per NEC 705.40 and E 1547 to prevent islanding, which poses a severe safety risk to utility workers. Option is incorrect without battery backup. Panels. C. Don't store energy. Option D is not feasible unless a DC architecture exists. Automatic shutdown ensures safety, system integrity, and regulatory compliance. Question 9. With respect to grounding requirements in a solar PV system, what is the primary purpose of bonding all metallic, non-current carrying components? A. Improve inverter efficiency. B. Reduce voltage output from panels. C. Provide a low resistance path to ground in case of faults. D. Prevent moisture accumulation inside junction boxes. Answer. Correct answer. C. Explanation. Bonding ensures all conductive surfaces are at the same electrical potential, minimizing shock and fire risk per NEC 690.43 and 250.92. A low resistance grounding path allows safe fault current dissipation. Option is irrelevant. Option B misunderstands panel output. Option D is not an electrical function. Grounding and bonding protect life, equipment, and ensure inspection approval. Question 10. When considering integrating a solar PV array with an existing HVACR system, ISTACHEN aims to optimize energy use during peak demand periods. The facility has variable refrigerant flow VRF systems and real-time energy monitoring. Which strategy will best help reduce HVACR energy draw from the grid during peak hours? A. Use a timer to turn off HVAC during peak times. B. Install a demand controller to manage HVAC loads and PV interaction. C. Disconnect HVAC from the PV system to prevent interference. D. Run HVAC only at night to avoid daytime grid usage. Answer. Correct answer. B. Explanation. Demand controllers paired with real-time monitoring can dynamically adjust HVAC loads based on solar PV output and utility rates. This approach is consistent with ASHRAE 90.1 energy optimization and aligns with demand-side management strategies. Timers A. Lack flexibility. Disconnecting C. Negates integration benefits. Running HVAC at night. D. Is impractical in hot climates. Control maximizes efficiency and cost savings while keeping occupant comfort. Question 11. Through careful analysis of a recent installation, technician Maria notices that the rooftop array on a multi-tenant building has inconsistent energy output among identical strings under the same irradiance conditions. She verifies that shading is not present. What should Maria do next to diagnose the root cause of this imbalance? A. Replace the inverter immediately without further testing. B. Inspect string-level wiring for high resistance or loose connections. C. Assume it is a module manufacturing defect and contact the supplier. D. Wait for system self-correction due to temperature equalization. Answer. Correct answer. B. Explanation. Inconsistent string output under identical irradiance is often caused by voltage drops from high resistance or loose connections. NEC 690.31 mandates proper conductor installation to prevent such inefficiencies. Before assuming inverter or module failure, checking for poor connections or faulty wiring at the string level is essential. Waiting or replacing parts without root cause analysis is ineffective and may violate NEC 110.12 on workmanship. Question 12. In the context of inverter installation, what is the most critical consideration when integrating a solar PV system with an HVACR unit that includes variable speed compressors and advanced electronics? A. Ensuring the inverter has a high surge capability for startup loads. B. Matching the inverter voltage exactly with the HVACR control voltage. C. Avoiding any DC disconnect near the HVACR unit. D. Using microinverters exclusively to prevent harmonics. Answer. Correct answer. A. Explanation. HVACR units with variable speed compressors have high inrush currents. The inverter must handle this load, particularly during compressor startup. NEC 705 Point 6. B. Requires compatibility between interactive systems. Surge capability is more important than microinverter use in this context, and voltage matching is less critical than ensuring the inverter can supply dynamic loads. Question 13. During the process of commissioning a solar-powered HVACR system, engineer Ista Patel observed significant voltage drops at the combiner box despite proper inverter settings. The wire length from the array to the combiner is approximately 60 meters. What factor is most likely contributing to this issue? A. Use of high-voltage inverters without a buck converter. B. Incorrect calculation of ampacity for temperature derating. C. Insufficient conductor size causing excessive voltage drop. D. Incorrect inverter grounding scheme. Answer. Correct answer. C. Explanation. Voltage drop increases with distance and insufficient conductor size. NEC 310.15b and NEC 690.31b. Stress proper wire sizing and derating to avoid performance loss. Long wire runs must account for conductor resistance, not just ampacity. Grounding and voltage conversions are less likely to impact voltage drop directly in this scenario. Question 14. The general consensus is that battery storage plays a vital role in supporting HVACR systems during power outages. What is the primary design consideration when sizing a battery system for such use? A. Daily peak irradiance at the installation site. B. HVACR unit voltage, phase and frequency. C. Total expected load duration and current draw. D. Location of the main service panel. Answer. Correct answer. C. Explanation. Battery sizing must align with the duration and amperage of the load. HVACR units can be demanding, and NFPA 7-tie and NEC 706.10 dictate that energy storage systems must be capable of sustaining critical loads for required time periods. Location or irradiance affects charging, not discharge sizing. Question 15. Under the assumption that a installer is integrating solar with a hybrid HVACR system in a location prone to grid outages, which component becomes essential for uninterrupted power delivery to HVAC loads? A. Grid-tied string inverter with automatic restart. B. Transfer switch with load shedding capability. C. A PT controller with anti-islanding feature. D. Transformer coupled combiner box. Answer. Correct answer. B. Explanation. Hybrid systems in outage-prone areas need transfer switches to isolate critical loads and prioritize power delivery. Load shedding ensures HVACR systems do not overdraw from limited sources like batteries. NEC 702.4 covers standby power integration, and transfer switches are a key part of compliance. Question 16. To what degree does the presence of metallic raceways on a rooftop solar PV array affect grounding and bonding requirements under NEC 690.43 and 250? A. No additional bonding is needed for metallic raceways. B. Only the panel frames must be bonded. C. Metallic raceways must be bonded to the equipment grounding system. D. Metallic raceways must be isolated from ground to prevent current loops. Answer. Correct answer. C. Explanation. NEC 690.43, C, and 250.96 require bonding of all metal components that could become energized, including raceways. This prevents shock hazards and facilitates fault clearing. Isolating raceways is incorrect and unsafe. All conductive enclosures and raceways must be part of the equipment grounding system. Question 17. Based on the information provided in a job site inspection, technician Green is preparing to install rooftop solar panels using a ballasted racking system. The building has a membrane roof and is located in a high wind zone. What additional design element must Green prioritize? A. Using lightweight flexible panels to reduce uplift. B. Adding ballast weight to comply with wind uplift requirements. C. Bonding racking directly to HVACR units. D. Increasing tilt angle to reduce wind drag. Answer. Correct answer. B. Explanation. Ballasted systems in high wind zones must comply with the C716 wind loading standards and NEC 690.4b. Increasing ballast ensures the system remains secure under uplift pressure. Flexible panels and tilt adjustments do not substitute for proper ballast. Bonding to HVACR units is neither required nor advisable. Question 18. When analyzing the energy yield of a solar PV system powering an HVACR compressor, what parameter most significantly affects daily output performance? A. The latitude of the installation site. B. The amperage rating of the inverter. C. The pitch of the roof surface. D. The solar insulation level. Answer. Correct answer. D. Explanation. Solar insolation directly correlates with how much energy a system can produce daily. It reflects the total available solar energy. While site latitude affects insolation indirectly, it is not the dominant metric for energy yield forecasting. NEC 705.10 encourages proper system performance prediction using local solar data. Question 19. A detailed analysis of a hybrid HVACR EV system reveals that the HVACR equipment is producing erratic performance during the evening hours. Technician Lewis notes that battery voltage remains stable, but load switching occurs frequently. What is the most likely root cause? A. Solar array is underproducing due to panel aging. B. Inverter is overheating from continuous cycling. C. Load management controller is misconfigured. D. HVACR system is drawing power beyond inverter surge limits. Answer. Correct answer. C. Explanation. Frequent load switching despite stable voltage suggests controller misconfiguration. Load controllers must be properly calibrated to HVACR cycling behavior. NEC 705 and 706 require reliable controls for hybrid systems. This is more likely than aging panels or thermal inverter faults during night hours. Question 20. Among the various grounding techniques available for PV systems, which of the following is most suitable when bonding multiple rows of ground-mounted arrays connected to a centralized inverter, using isolated ground rods for each array row? B. Running a continuous equipment grounding conductor across all rows. C. Bonding only the inverter and not the arrays. D. Grounding through conduit only without any bonding jumpers. Answer. Correct answer. B. Explanation. A continuous equipment grounding conductor ensures all arrays are at the same ground potential, minimizing shock and fire hazards. NEC 690.43 and 250.122 support this method. Using isolated ground rods can create voltage differentials. Bonding only the inverter or relying solely on conduit is non-compliant. Question 21. A technician installs a ground-mounted PV system near an HVACR chiller plant. What is the most important consideration regarding induced voltage from nearby equipment? A. Bond the array to the AC neutral conductor. B. Install a separate isolation transformer for the chiller. C. Ensure proper equipment grounding and separation of vac circuits. D. Run DC wiring in unshielded metallic conduit. Answer. Correct answer. C. Explanation. HVACR equipment can induce electromagnetic interference in PV systems. NEC 690.31 and 300.3b require separation of AC and DC conductors and proper grounding to mitigate interference and prevent false tripping or voltage feedback. Shielding or bonding to neutral is not compliant or effective alone. Question 22. When retrofitting an EE to mount an HVAC-equipped rooftop, which of the following requires reassessment to avoid violating structural integrity codes? A. The rooftop access path location. B. Roof drainage slope toward HVAC units. C. Dead load capacity including ballast and PV modules. D. Existing thermostat control location. Answer. Correct answer. C. Explanation. Adding PV modules changes the roof's dead load, which must be reassessed under IC and NEC 690.4d to ensure the structure can support it, especially near HVACR systems. Thermostats and drainage are secondary concerns, while access is important for code but not structural integrity. Question 23. During inspection, a ground fault is suspected in an E array supplying an HVACR unit. Which diagnostic step should be performed first? A. Replace all module connectors. B. Conduct and insulation resistance test between conductors and ground. C. Disconnect the inverter and reset the breaker. D. Inspect HVACR compressor wiring. Answer. Correct answer. B. Explanation. Insulation resistance testing identifies ground faults per NEC 690.5 and 690.41. Its primary diagnostic step before replacing hardware or resetting breakers. Inspecting the HVACR side without testing the array first may miss the fault's origin. Question 24. An installer integrates the e-UTM with an HVACR package unit on a commercial rooftop. Which of the following is a co-compliant strategy for rapid shutdown? A. Disconnect the inverter using the HVACR control panel. B. Use module-level electronics that comply with NEC 690.12. C. Ground the array through the building HVAC neutral. D. Install a mechanical disconnection switch 20 feet from the array. Answer. Correct answer. B. Explanation. NEC 690.12 requires rapid shutdown within 30 seconds and specific voltage limitations outside the array boundary. Module-level electronics like optimizers or microinverters ensure compliance. Mechanical switches far from the array may not meet this requirement. Question 25. While inspecting a solar-integrated HVACR system, a technician notices arcing in a combiner box during compressor startup. What is the most probable cause? A. Improper bonding of HVACR control circuit. B. Undersized DC conductors for current surge. C. Overvoltage from lightning exposure. D. Failed microinverter capacitor. Answer. Correct answer. B. Explanation. Compressor startup causes inertia current, and if DC conductors are undersized, they overheat or arc. NEC 690.8 and 310.15 require correct ampacity, including temperature and conduit fill adjustments. Lightning or capacitor failure is less likely during startup. Question 26. What NEC article governs energy storage system S installation when paired with PV or HVACR backup applications? A. 705, B. 690, C. 706, D. 110. Answer. Correct answer. C. Explanation. NEC Article 706 governs S installations, including integration with PV and backup loads such as HVACR systems. Article 690 governs PV systems and 705 covers interconnection, but 706 specifically addresses batteries, charge controllers, and safety mechanisms. Question 27. What is the most critical risk if a solar array's output exceeds the ampacity of conductors feeding an HVACR unit? A. Unstable HVACR compressor cycles. B. Overcharging of the solar battery bank. C. Conductor overheating and fire hazard. D. Reduced solar array voltage. Answer. Correct answer. C. Explanation. Exceeding conductor ampacity causes overheating and can result in fires. NEC 310.15 and 690.8 require conductors rated for continuous and maximum expected currents. This is more dangerous than voltage drop or reduced performance. Question 20. A solar PV installer is connecting a combiner box located outdoors and 30 feet from the inverter. Which installation element is required for code compliance? A. Flexible PVC conduit for thermal expansion. B. Ground fault protection for HVACR circuitry. C. DC disconnect between combiner and inverter. D. Shielded cabling to prevent IMI. Answer. Correct answer. C. Explanation. NEC 690.13 requires a re-connect between the array and the inverter unless located in the same enclosure. The outdoor combiner's distance mandates separate disconnect for service and emergency purposes. Question 29. In a system using microinverters connected to a rooftop HVACR unit, which of the following best supports system monitoring and diagnostics? A. Grounding electrode conductor length of 10 feet. B. Arc fault circuit interrupters at each branch circuit. C. Manufacturer provided module level monitoring software. D. Insulation rated pull boxes on every HVACR wire. Answer. Correct answer. C. Explanation. Microinverter systems often include module-level monitoring, helping detect string faults or power fluctuations affecting HVACR operation. NEC 690.11 and manufacturer specs encourage fault identification, and software is the most efficient method for pinpoint diagnostics. Question 30. An HVACR technician working near a rooftop PV array wants to disconnect the solar feed to service a unit. What is the code-compliant action under NEC 690.13 and 690.15? A. Unplug the modules from one another. B. Open the rooftop disconnect labeled. E. Disconnect. C. Shut off the building main breaker. D. Open both AC and DC disconnects at accessible locations. Answer. Correct answer, D. Explanation. Both AC and DC disconnects must be opened to isolate PV power sources safely. NEC 690.13 DC and 690.15 AC require serviceable, labeled, and accessible disconnects to ensure technicians working near or on HVACR systems are not exposed to energized parts.